All right, first things first, we're gonna finish the chart here. There's missing spaces. This stands for this TTL stands for total. It's not plus plus one. Now, here we go. What plus 19 gives you 32? How would you even figure that out? You'd subtract 19 from 32. So if you do that, you're gonna get 13. So 13 goes here. How do I check? 13 plus 19 equals 32. That's correct. So now I know 13 goes there. What else can we figure out? What about, can we figure out this one? Because now this has two numbers in it. So now I can figure out the bottom of this. So now it's gonna be 41. Okay, now I have two numbers here. I can figure out the last one here. You see the pattern? If you're just trying to finish, these numbers down here are totals of these columns. The ends are the totals of the rows. So 41 and 34 is gonna give me 75. Then I have 32 plus something is gonna give me 75. And that's gonna be 43. So 43 is gonna give you 75. Now you have to think 19 plus something gives me 34, or you can think 28 plus something gives me 43. So 28 plus 20 gives you 48, subtract 5, so let's say 15. So this is 15. Double check, yep, perfect. Okay, so that's gonna be the first stuff you're gonna be doing on this section. The second thing you're gonna be doing is answering questions about it. So if I said, how many people in city A said no to rain boots? You have to figure out where that is, and that's right here, 19. What if I said, how many people said no in total of both cities? Where is that? Well, people that said no are here, so the total is this 34 down here. And what if I said, how many total people were asked questions? Where is that going to be? Down here in 75. Okay? So, pretty simple concept. Nobody in class had any issues with it. Let's go to the next one. This one we'll have to talk about. Okay? The first part was very easy, but then when I tried to throw something off with row and column, then there was a whole issue with it. Okay? So first thing, if they don't use the word row or column, we're going to be finishing this with percents, and you're going to be dividing everything by 200, the total of the entire chart. Okay? So, now, let's do, like it's going to be 80 over 200, 40 over 200, and 120 over 200. So those are going to be our division to find our percent. So if I do 80 divided by 200, okay? 80 divided by 200. You're going to add a decimal point. It doesn't go there, it doesn't go there. It's going to be a decimal point here. Add a 0. Then how many 200s go into 800? That's going to be 4. So that's going to be 0.4. But that's not what you're going to put here because you have to turn this decimal into a percent. And how do you turn a decimal into a percent? You move it twice. 1, 2, and there's a 0. So now it's 40. Okay? So now you have 40 here. So this is 40%. Okay? The next one, this is 40% of the total amount, which is 200. The next one here, okay, the next one here is going to be 40. Well, 40 is half of 80, so I can just assume that it's going to be 20. Okay, using basic arithmetic. So 40% plus 20% has to equal 60%. Now that's not true always, but it could happen. Okay, why is it making my dots like that? Okay, that was weird. Now, the next one, 50 out of 200. Now, I already know the answers to all these, so 50 out of 200 is going to be 25%. Okay, then it's going to be 15%, and that's going to be 35, 40%, and that makes 100%, which is what I want. Where the 100 is what you're dividing everything by. Now this is going to make 65%, and this is going to make 35%, and that's going to make 100 as well. So that works out. But that's if I don't use the word row or column. What happens if I do use the word row or column? What am I dividing by now? Does anything change? It does. If you say row, that means you're looking at every row on its own. Okay, so you'd be looking at just this information here. Just this row. So now none of the bottom exists. Just do each row individually. So now it's going to be 80 divided by 120, 40 divided by 120, and 120 divided by 120. Now, the 120 divided by 120 is 1. And if you move the decimal point from 1 twice, that's going to make 100%. Okay? Then we have to think how much is 80 out of 120 and how much is 40 out of 120. Now, 80 out of 120 is 2/3, which is 0.6 forever. And this one here is going to be 0.3 forever. Okay? So that's going to be, if I move the decimal point twice, remember there's 6's forever. If I move it twice, it's going to be 66%. But because there's a 6 after it, I'm going to round up and make it 67%. Okay? This one, I'm going to move it twice. 1, 2, remember there's 3's here. It's going to be 33.3%, which will round to 33. So 67 plus 33 gives us the 100%. All right? So that's what we're doing there. The 50 I would divide by 80, the 30 I would divide by 80, the 130 I would divide by 200, the 70 I would divide by 200. So it's now rows. The next one is going to be columns. So if I say columns, you guessed it, we're probably going to be doing something straight down like this, the columns. So columns are up and down. So if I said columns, it would be 80 divided by 130, then 50 divided by 130, and you get a percent. So all my 100% would be down here. This would be 100%. This at the end result would be 100%, and this would be 100%. Mr. Kessler, how is that possible? How is 100%, 100%, 100% make the 200%? That's not what we're looking. We're only looking down the columns. We're not, if they say column, we're not looking at rows anymore. We're only summing up down. Okay? When we're making the chart, you fill out everything like we talked about. But when they ask you to make a relative table, then you have to change everything into percents. And if they use the word row, it means stick with every row as its own entity. And column, it sticks to its own entity, but just columns. Okay? Pretty easy. Now here, our answers are 3 different things. It's going to be infinite solutions, 0 solutions, or 1 solution for these questions. So for this one, they have the same slope. Now on a graph, that means they're going the same speed up or down. Okay, but they're going the same speed. And here is where they start. Okay, so the example I was using with my kids here in the classroom where if they start on, like if you're on a staircase, right, and they start on different floors, okay, they're starting on different spots, they're starting on different floors, and they're going the same speed up this staircase. When are they going to be in the same place at the same time? Oh, well, they're going to be at the same place at the same time when never. One is always going to be above. They're never going to catch up because they're going the exact same speed, which means there are no solutions for this problem. Okay? So if they're going the same speed and start in different spots, they're never going to run into each other. They're going to be parallel lines. Look at this one. One is going faster than the other. So I don't even look at that. If there is ever different slopes, that means one person is going faster than the other. How many times are they going to run into each other? Once, when the faster person passes him. Or the other person is going too slow and the other person is going to pass him. Okay? So if the slopes are ever different, the answer is 1 solution. You don't have to think of anything else. Okay? So that one you see immediately. Now this one is not set up like these. You have to leave y by itself before you can comfortably say how many solutions it has. So before you can do anything, you have to get rid of the 3 in this problem. So if I'm getting rid of the 3 next to the y, I have to divide everything by 3. I don't know why it just went jumbo. I think I actually clicked on that. Okay? Divide everything by 3. So 3 divided by 3 is 1y, which is written just y. 6 divided by 3 is 2x minus 9 divided by 3, which is 3. Okay? So look at this and look at this. They started in the same spot and are going the exact same speed. When are they going to be at the same place at the same time? Well, they're always going to be in the same place at the same time. So this has an infinite amount of solutions. because they're always going to be at the same place at the same time. I have one more question for you guys. The question's over here. So this is going to be, so this one's already done. I don't have to move anything. This one has a lot of stuff we have to move. 2 whole things we have to move. So let's see how we're going to do it. What we're going to do is literally grab this 6x, okay, with our imaginations, and move it to the other side of this equal sign. Once you move something to the other side of the equal sign, it changes signs. So if I've moved this, it leaves the 2y all by itself. So now we have 2y all by itself. But we've moved the 6x to the other side. Now when that happens, when you cross into the other side, it changes the sign. So this becomes negative 6x plus 14. Now we have y with a 2 next to it. We could solve it just like we did before by dividing everything by 2. So if I divide everything by 2, y equals negative 3x plus 7. Okay? Now in this one, they have different slopes. One is negative 3 and one is positive 3. If they have different slopes, it is automatically one solution. Okay? And that's it. Very simple, easy work. I think that's as complicated as it'll get. You might have to move 2 different ones, but moving stuff isn't that difficult. All right, bye.